All right. Welcome, students. So in this chapter, we are going to talk about application of vectors. So what applications we are really interested in is how to find out equation of line and line segment in vector form, how to find out the intersection of two lines in the vector form, what is a plane, so how to find equation of plane in a vector form, then the concept of normal vector to a plane, then vector equation of line, and a point normal form of a plane. So these are the things we want to basically understand about vectors. Okay. So before we start, let's start with the following example. So you have a line. So line is given by equation y equals to mx plus b, where m is the slope of the line and b is the y-intercept, right? B is the y-intercept. So now to draw a line, you need 2 points. So we'll find 2 points. So let's take basically, suppose these two are the points on my line. Let me draw them. So 2 points are enough to draw a line, right? 2 distinct points are enough to draw a unique line. So I get if I take these 2 points, I get, say, suppose this is x0, y0, and this is x1. Suppose this point is x0, y0, and this point is x1, y1. Then you draw the line by finding 2 points. So we choose any 2 points really. Here, for example, I could have taken, so as I said, I took x equals to 0, I get y value. So I take x equals to 0 would give me y equals to b. That's one. The x equals to 0, y equals to b will give me this point here. And then when I take x equals to 1, I get y equals to m plus b. So it will be some point because here we don't know. So this is unit 1. Let's call this as 1. In that case, this will be 1 comma m plus b. Now this will change because depending on what kind of m and b we have, right? But it will be constant, nevertheless. So recall, what is the connection with the slope? The slope is same as, if I take 2 points, the slope, so this is your run, this is rise. How much did the graph rise over how much it ran? So the slope is rise over run. So if you want to take 2 points, let's suppose this point was x0, y0, and this point was x1, y1, then the slope can be defined as m equals to rise over run. So how much did it rise? Suppose it rose from x0, y0 to x1, y1. So rise would be how much did y increase in, or how much did y change? So y1 minus y0, and run is going to be what? x1 minus x0. This is rise over run. You can also think about it as delta y over delta x, change in y over change in x. Right. So in that case, this is your delta x all the way from here to here. And this will be your delta y here. Okay. Now, if this angle is theta, then we know this angle is also going to be theta, and then that is going to be tan theta is opposite side, which is this side, which is y1 minus y0. So tan theta is y1 minus y0 divided by this length, which is going to be x1 minus x0. So the slope can be also given by m equals to tan theta. So you see that here you can see that this gives the direction, right? The angle it makes with the x-axis and tan of that. So this gives you a direction. So the slope can be interpreted as something which gives a direction. And what is the intercept? Intercept is basically if you have y equals to mx plus b, then when you put x equals to 0, when you put x equals to 0, you get y equals to b. So we get when x is 0, so y of 0 equals to what? M times 0 plus b, which is b, which is essentially the same thing as if your line cuts this. So when x is 0, you are here. So this point will be b. So 0 comma b. So this is the intercept. Okay. So again, if you look at this, the key idea is the following. The key idea is that if you have a line like that, you start with one point and then give a direction in which you want to go. Okay. So you can start here. So you start here. And then the direction gives you to go which way. Yeah, which way on both sides though. Okay. That's the idea behind the line. So let's try to see this equation in a vector form, or more generally, a line in 2 or 3 dimensions determined by a point x0, it's a vector, and a direction d. So the point x0 is basically the same as saying you're looking at position vector of that, right? So you have point x0. If I give you point x0, then I tell you which direction to take. Like, there are many directions to take, but if I fix one direction as this, the other direction is this. But if I also give you direction with that, I give you a point, and if I give you a direction, say suppose I say you have to go in this direction, then you know which way to go. Okay. So how can we describe a point on the plane? Right? So we give a point and then we give a direction. So any point on this plane can be reached by starting at a point x0 and then moving from there in the direction of, if this d is the direction, generally we like to give it as a position vector of something, so that's why the d is drawn in a different way. Then what I will do is we'll go in this direction, which is d, or we'll go in the other direction, which is minus d. So you go in both direction and you get the line. So that's the idea behind a line. So you have a point and you have given a direction associated to it, which direction to go, and that will define uniquely a line. So then the question is the following: how can we describe the points on this line? Any point on this line can be reached by starting at x0 and moving from there to direction of d or minus d. In other words, it is x0 plus vector td, right? So why is that? So you have, so note that x0 is given by if the coordinate of this is x0, so this will be the vector corresponding to it. You want to give equation of this guy here. Right? So, and then you join this. So you want to give, so what I really want to give you is vector equation of points, these points, right? So all of these points. So the way I'm going to do that is as follows. So I'm going to basically say, okay, I want to give you what is the equation of this point. It's a vector equation of this point. Suppose I call this point as xy. If this point is xy, then the position vector of this point is going to be vector x, vector y, right? Now, this whole thing is d. This is also d. So this part is just some scaling of d, right? So this is going to be t times d. So you have x0 plus d. Now use triangle law of vector addition. So you'll get xy equals to x0 plus t times vector t. So voila, there we go. So we got basically a vector equation of a line. Let's look at some example. So the way it works is that as you keep changing t, you will get all the different points, right? Because there are infinitely many points. So all the points are on all the points x on this line then can be obtained by varying t. Okay. So we should use x. So I'm going to use a notation which is, say, vector x, and then I'll call it as, just for the sake of, I'll call it as x1, x2. Here I'll call it x1, x2. And note that there's no harm in calling it as x comma y. Okay. So let's try to understand this now. So what is the vector equation of line? A vector equation of line is vector x equals to x0 plus td, where t changes from minus infinity to infinity. And as you keep changing t, you get all the points. So such a t is called parameter, because as you keep changing t, the parameter is just a language saying that as you keep changing this t, you will get all the points on your line. Okay. Now, this is true for any dimension, not just for 2 dimension. This is true in general. Yeah. So let's look at the following example again. Yeah. So idea is clear. If you're given a point, so given point in the vector, so position vector of point, and direction d, equation of line is what? Equation of line is x0 plus t times d, where t is a scalar, okay? And x0 and t are dr. X0 and dr, so these are vectors. They have arrow on top of them. Okay. So let's look at an example again. Suppose I give you an equation like that. Suppose I have x equals to some starting point, say 1, 1, or say minus 1, 1, plus t, comma 1, 1. So again, in this case, you can see this gives you the direction. Now let's try to find out a few points on this and convince ourselves that equation of this form is indeed a line, right? So let's look at few values. So in this case, I have t, take x, take y. Now I'll say, where did x and y come into the picture? So this vector x, capital X, can be written as capital X, vector x comma y. And then you can combine this together. So you get minus 1, 1 plus t, t. And then how do you add vectors coordinate wise? So now let's find out a few points here and see whether they stand in a line or not. So you have t equals to 0, then x is, look at the first one, it's going to be minus 1, and y is 1. When t is 1, The first coordinate is 0 because I'm substituting here. This is my x of t. And my y of t is 1 plus t. So I get when y will become t plus 1, so 1 plus 1, which is 2. And then the third option, take anything. Say x equals to minus 1, in that case, sorry, t equals to minus 1. In that case, x will become minus 1, which is minus 2, whereas y will become 0. Okay, so let's draw this. So if we draw this, I'm going to draw the negative side as well because I need, and I also need negative y values too. Okay, so when x is minus 1, y is 1. So when x is minus 1, y is 1. So this is 1 point. When x is 0, y is 2. Okay, so when x is minus 2, y is 0. So when you join them, you can see that they indeed lie on a straight line. So what is the idea then? How will I deal with the general case? I'll deal with the general case as following. So suppose I have vector x, which is x0, y0, and this vector x is actually x of t, y of t. So this is a position vector of point plus direction. So let me just write down the direction as t dx dy. It's just to indicate that these are the component. This is an x component and this is a y component. Okay. So in that case, we get x of t equals to, when you add things up and write it down, you get x0 plus, we get xt equals to x0 plus t dx, and we get yt equals to y0 plus t dy. You must be wondering why there's x of t and y of t, because it changes, the x and y value changes, yeah, as we keep changing t. So our notation show that lines are just lines no matter what the dimensions are, right? So in this case, what are we trying to find? We are find x of t, y of t is a vector instead of y equals to mx plus b. Okay, so this is what we do in vector form. So if you asked vector form, this is what is in the vector form. Let's look at an example. Find the vector equation of line and component equations. So these things are called component equation. So the question is, okay, so find a vector equation and component equation of line that passes through 1, 4 and is parallel to d equals to minus 2, 3. Okay. So what is the vector form? So we have vector form is simply x of t, which is same as x, y, which changes as a function. So let me just write it as x of t, y of t. That is going to be 1, 4 plus t times, so it's basically what? It is this thing in vector form. So 1, 4 plus t times the direction. The direction is given to you as -2 and 3. So this is your vector form already. Now from there, what do we get? How do we get the component equations? So component equations, you need to combine these things. So this implies x of t, y of t equals to 1 plus, actually the first part is going to be -2t. And then you have 4 plus 3t. So therefore, component equations are, again, this is just a naming, right? You're just reading the components from there. So component equations are xt equals to 1 minus 2t and yt equals to 4 plus 3t. That's all. Now, suppose I ask you, find few points on this line. How do you do that? Well, as they keep changing t, you will get different points, right? So let's take, for example, t equals to 0. If you take t equals to 0, you'll get x of 0 is going to be 1, 4 plus t times. So that is 0, right? So you get 1, 4. That is what one point is 1, 4. Yeah, distinction is this is a vector, position vector. This is just a point. Similarly, if you take t equals to 1, take this equation now. When you take t equals to 1, you get what? X component is what? You get x of 1, 1 minus 2, which is -1, and 4 plus this, which is 7. Right? So what you do is you substitute in this here. Right? Now let's find a few more points. So let's say what is when t equals to -1. Then we get x of -1 is -1 minus of minus. So we get 1 minus 2 times -1, which is going to be 1 minus 2 times -1 for the x component. And for the y component, we'll have 4 minus 3, which is going to be 1 plus 3 and 1. Okay, so we want to draw this line. So to sketch a line, we just need 2 distinct points. So let's take 2 points of your choice. So let's take 1, 4, for example. 1, 2, 3, 4. This is 1 point, 1, 4. And the other point is 3 minus 1. So 3, 2, 3, 1. So when you join this, we can now think about the position vector of this point is x of -1, which is 3, 1. Yeah, by position vector, I mean this vector. And here we have x of 0. So this is position vector corresponding to, so x of 0 is 1, 4. Okay, so this is your vector x0. So now what are some points which are not on plane, not on this line? Now clearly take a point here, right? So this is 1, 2, 1, 2, 3, 4, 5, 6 for x, and then 1, 2, 3, 4. So 6, 4 is not on line, right? Now, how, if somebody asks you, then how do you check this? You can say, well, substitute, right? So substitute in this equation. you will get what? You want x of t to be 6, 4. And see if there is something which satisfies that. You have, what is the equation? Equation was 1 minus 2t. Then we have what? 4 plus 3t. And we want to show that there's nothing which satisfies this equation. So there's no t which satisfies this. So no t such that this is true. And you can check that there's no such t, right? So how do you go about that? Well, you can try to solve this equation simultaneously and show that there's no such t. Okay. All right. Now the question is, find the equation of this line in ax plus b equals to c format. Which line? So you're given x of t equals to, or we have x component is 1 minus 2t, and we have y component is 4 plus 3t. So how do we do this? So we want to write it in terms of x and y. There should not be t. So the step is, so how do we do that? So we need to get rid of t. Yeah, the best way to get rid of t is to solve for t and equate it. So step 1, solve for t. So how do we solve for t? We'll just basically say, okay, we have x equals to 1 minus 2t. This means 2t equals to 1 minus x, or t equals to 1 minus x divided by 2. That's one. Similarly, for the second equation, you get what? You get y equals to 4 plus 3t. This would mean y minus 4 divided by 3 equals to t. We have equation 1 and 2. They are both representing t, so equate them because this side and this side are equal. So we get 1 minus x divided by 2 equals to y minus 4 divided by 3. So this would mean bring x and y on both same side. So we get, first of all, we'll multiply throughout by 6 because I want to get rid of the denominator. So I get 3 times 1 minus x. So 2 times y minus 4. Then I simplify, so I get 3x minus, 3 minus 3x equals to 2y minus 8. Bring this on this side and that 8 on the other side, so we get 3 plus 8 equals to 3x plus 2y. That is, we get 3x plus 2y equals to 11. So this is the equation of your line. Okay. Now let's do other way around. So find the vector equation of a line 3 minus 1, 2. So how do we do this? So we need a point. So what do we need? Need a point. And second, need direction. Now to need if you need a point, just substitute, right? So let's say, how do we do this? So let x be 0. This will imply, if you substitute in this equation, so 3 times 0 minus y times 1. So 3 times 0 times y equals to 2. So this will mean y equals to negative 2. So we got point. The point is what? The point is, that is 0 comma minus 2 is a point. Yeah, it's traditionally called, what is, you have called all this for time x0. Now you need direction. So how do we do this? So we have 0, -2 on this guy. So note that how do you find a direction of a vector? So if I give you 2 points, x1, y1, and x2, y2, then direction is y2, so x2 minus x1, comma y2 minus y1. Okay, yeah. So this is how you get the direction. So in this case, we need to find another point to do this business, right? So need a point. So what are the steps? So steps can be thought of as steps. Find a point. So that will give you x0. Now to find d, you need 2 points, right? Because then you can compute it this way. So what do we do is step 1, step 2, find another point. So let's take, say, x equals to 1. Say x equals to, say, this would imply what? 3 times 1 minus y equals to 2. Or we get 3 minus 2 equals to 1 equals to y. So therefore the point is 1, 1 point. Now note the relation between point and the vector. It should be clear, right? So how do we construct the direction vector d? So if I call this as, if I call x0 to be vector 0, -2, and I have x1 to be vector 1, 1, then my direction d is given by 1, 1 minus 0, -2. That is, I'm looking at x1 minus x0. Yeah. Now, why is that? Again, let me recall why is that the case. So if you have a line like this, you have 2 points, say x0. So the direction of this vector, so this is what x0 vector is, right? So this is my vector x0. Then I have another point, say x1, and corresponding to that, I get another vector x1. So then the question is, what is this? What is the equation of this guy, right? Which is giving you the line. Or if you want a direction of this, use triangle law of vector inequality. Sorry, triangle law of vector addition. So we have vector d plus x0 equals to x1, right? Because of this is in the same direction, this is in the same direction, and then x1 is going to be in the opposite direction. So we get d equals to x1 minus x0. Okay, so this is a formula you need to know. And this is a derivation of it. So we get x1 minus x0. So it's 1 minus, this is going to be 1, and 1 minus of minus, so that's going to be 3. So this is my d. Therefore, what is the vector equation? So what is my vector equation? My vector equation is given by x of t equals to x0 vector plus td, which is going to be x0, we have 0 minus 2, and t times vector d. And what is our vector d? Vector d is 1. So this is our vector equation of a line which is given by 3x minus y equals to 2. All right, let's proceed further. So this is how we deal with lines. So now we have understood the following. If I give you a vector equation of line, how to go to scalar equation of the line, that means of form ax plus by equals to c. And then if I give you scalar equation, how to go to the vector equation, okay, and vice versa. So that thing is what we are discussed so far. Now let's talk about plane. So if I give you a point, there are so many planes which can pass through it, right? There's this plane which can pass through it. But if I fix the vector which is perpendicular to the plane, it kind of basically not let the plane wobble. Yeah, right? It will basically fix the plane as well. So that is the key part. So the orientation of plane is determined by a normal vector. And what is the normal vector? A vector which is basically, if you have a plane like this is your plane. Let's call this P. Normal vector is basically a vector which is perpendicular to the plane. Okay. So there's like kind of points off the plane, really. So for example, if we take normal vector, if it is XY plane, then how do we understand XY plane? The normal vector is what, right? So you have, this is XZ, right? XY plane. Then the normal is given by what? By the vector Z in the direction of Z. So in that case, we have N is given by 0, 0, 1. Okay, and so a normal vector is an orthogonal or perpendicular vector to the each vector on the plane. That's what normal means. So the idea is normal vector is perpendicular to every vector on the plane. So if these are the vectors inside the plane, you can see it makes a 90-degree with all of them. Now, just to make a connection of what we know, suppose we have a plane X, we are talking about XY plane. So we have Z component 0. And then the normal to this plane is given by 0, 0, 1, right? So in that case, what do we get? We get the following. So we have to make basically, so you can see that these two vectors are perpendicular, right? So if you take any point here, it will be X, Y, so if we have, if this was my XY plane, then any point is given by X, Y, 0, right? So any point is given by X, Y, 0. That means, so I have any point. So let's take any point here. This point is given by X, Y, 0 as a point. So I don't need the vector. And consequently, this vector will be given by this vector, position vector of this point is given by X, Y, 0. And you can really check that what happens in this case. The normal is actually 0, 0, 1, right? Because when we drew the XY axis, XYZ axis, then clearly Z axis was perpendicular to XY axis. And then the vector which is in direction of Z axis is given by 0, 0, 1, which is your J, sorry, which is your K vector, right? So you can clearly check that these two are perpendicular. Why? Let's take the dot product. So we get X dot 0 plus Y dot 0 plus 0 dot, it could be not 0 dot 1, which is 0. So they are perpendicular, right? So these are perpendicular. So statement is normal vector to a plane is perpendicular by definition to every vector in the plane. Okay, let's see what leverage does it brings us. Now, this statement itself will help us to find out the equation. Let's see how. So note that a plane has infinitely many normal vectors. They all lie in the same or the opposite direction. Yeah, why is that? Well, take this vector, multiply this vector by 2, multiply this vector by 3, multiply this vector by 4, right? Or minus 1, minus 2, minus 3. So there are infinitely many normal vectors to a plane, and they are either in the same direction if it is a positive multiple, or in the negative direction if they have a negative multiple. So then the question is, if I how to find equation of plane? So first things first, we'll try to find out normal to the plane. So if I'm given this plane P, I want something which is perpendicular to this plane. Now, how do I do that? Remember, this is where the cross product comes handy. So what does cross product tells you? If you take two vector P2 and P3, so what is this vector? So the first vector is P1, P2. And you cross it with P1, P3. Then by right-hand rule, the thumb will give you the direction, and this guy is going to be perpendicular to both. Okay, so this is normal to our plane. Okay, once you understand this, then we are good to go. So it's like basically a three-legged stool, and the stability is provided by the normal. Okay. So first of all, let's look at the following problem. Find a normal to the plane that contains 3 points, P1, P2, P3. So again, let's just draw them like that. So I'll find P1. Say suppose this is my P1. This is P1. This is P2. Suppose this is P3. So I need to compute, say, vector. Let's call this as vector U. And let's call this as vector V. And then the normal is the cross product of these. So let's see how do we proceed. So what is my vector U? My vector U is joining P1 to P3, sorry, P1 to P2, vector P1, P2, and recall by component-wise subtraction, we get what? So we have P2 is this, P1 is this, so 4 minus 1, 3 minus 1, 4 minus 1. This is going to be 3, 2, 3. Similarly, what is my vector V? The other vector is P1, P3. In this case, it's going to be, again, it's going to be component of P3 minus component of P1. So P3 is so 3 minus 1, 2 minus 1, minus 1, minus 1, which is going to be 2, 1, minus 2. So these are the two vectors though, okay? Now to find the normal, we'll take the cross product. The cross product will be perpendicular to the plane, so we can use that as a normal vector. So my normal vector is going to be vector U cross vector V. So recall, what is the formula for that? The formula was, so recall, it is going to be, the first one is going to be, let me just write it down. So U2 V3 minus V3 U2. And then you move it cyclically, right? So you have U3 V1 minus V1 U3. And the last one is U1 V2 minus V2 U1. Okay, so let's see, what is the first one? I get U2 V3. The U2 is this U2 V3, which is 2 times minus, so it's going to be 2 times minus 2 minus V3, which is minus 2 times U2, which is going to be, U2 is going to be, so U2 is going to be, so we have 2 times minus, so 2 times minus 2, then minus V3, which is going to be, oh, hold on, this is not correct, right? So we need what? U2 V3 minus, then we have U3 V, so we have U3 V2, right? And then you replace, swap it. So 2 goes to 3, and then the 3 goes to 1. You have 3 goes to, yeah. So you have U1 V3. And then here you will have, again, moving in the cyclic order, we have U1 V2 minus what? Minus U2 V1. So what do we get? We get 2 times minus 2 minus 3 times 1. Then we get what? U3 V1. U3, again, 3 times V1 is going to be 2 minus U1 V3. U1 is 3. V3 is minus 2. And similarly, the last one is 3 times 1 minus 2 times 2. And when you sub it in, you get minus 7, 12, minus 1. So this is a simplification. So you get n equals to this. Now, okay, so let's check it out now. So we get this thing here. So there are a few guarantees we need to check. Just so let's check. So n is perpendicular to both u and v, right? So let's check n dot u and just check n dot v. We don't need to check it because if our arithmetic is correct, the answer should be 0. But let's just check it anyway. Dot with u, which is 3, 2, 3. And here we have minus 7, 12, minus 1, dot with 2, 1, minus 2. We get what? Minus 7. So we get minus 21 plus 24 minus 3, which is 0. That checks out. And then here we get minus 14 plus 12 plus 2, also 0, checks out. So what do we get? We get, indeed, these are perpendicular. So this defines direction. This defines the direction you must not go if you want to remain in the plane. So normal is exactly where you wouldn't go. So now, how does this help us to find the equation of the plane? So if you're given a normal n, like that, and so a plane is described by a point P0 and a normal n. Okay, so suppose you have point, so you have a starting point P0, and you're given, so now the plane could be wobbly around P0, right? Now, moment you give it a normal, it basically becomes fixed. Okay. All right, so we'll continue this in the next section.